So this is a quick video to show you some tips and tricks for factoring quadratics. So if you're having some problems with factoring, this is the place for you. All right, so when you're doing factoring quadratics, one of the first things you want to do is kind of go through a mental checklist of different things that you can do to equations, or in this case expressions, to help you out. So the first one I would recommend is, can you take a GCF out? Can you take out a greatest common factor? Is there anything that is common between all your terms that you can take out to make your quadratic expression a little bit simpler? Okay. Next one would be, is it a simple factoring type of problem? All right, if not, all right, it's probably going to be an advanced factoring type of problem. Okay, so we're going to go through we're going to see all those things going out in play in these three problems. All right, so let's do these one at a time. The first one, here we go. So the first thing you want to do in your mental checklist is, can you take greatest common factor out? In this case, you have 10 and 24, but you have no number, or you have a 1 in front of the x squared term. So there's nothing you can take out of all three at the same time. So there is no greatest common factor, which means we go to the second step. Is this a simple factoring type of problem? And the answer would be yes. All right, we know it's yes because there's no number in front of the x squared term. That a value is a 1. So we can do like a simple factoring. Okay, the way I like to do it is I put down my x's in the parentheses. Okay, then I can see that that first sign is going to be positive, so I'm going to put that positive right there. Then I tell myself, okay, what times that positive that I just wrote down would give me a positive 24? Well, a positive times a positive gives you a positive number. All right, and then lastly what I do is I find the factors of 24. So you got 1 times 24, you got 2 times 12, you got 3 times 8, and you have 4 times 6. Now, if your signs in your parentheses are both the same, you're going to add the two factors that you come up with. If their signs are different in your parentheses, then you're going to subtract. So we want to find, since they're the same, two numbers here that add up to be 10, and that would be 4 and 6. So I'm going to put the 6, the bigger number, in front, and there you go. We just factored your problem. Okay? Next, again, you go through the mental checklist. Can you take out a greatest common factor? In this case, you have 3, 9, and 162. Then you have x to the third, x squared, and x. So in actuality, you can take out two different things. All the numbers in this problem can be reduced by 3. So we're going to take a 3 out. And you have an x in each one of the terms. So we can take an x out. All right. And then what we do is we figure out what was left over. So if we divide all these terms by 3x, 3x to the third divided by 3x gives you x squared. Negative 9x squared divided by 3x gives you negative 3x. And negative 162x divided by 3x gives you negative 54. Okay, so we've done the greatest common factor. We've taken that out. And what we're left with is a simple factoring problem again. So we have to do that now. So we're going to rewrite the 3x because it's still part of our problem. But then we're going to do the same kind of steps that we did in the last one to factor what we have left. So I'm going to write my x's. I'm going to take that first sign that I see on the 3x and make it, which is negative, so I'm going to make that a negative. Then I tell myself, what times a negative would give me a negative 54? That'd have to be a positive number. Okay, so now I find the factors of 54. Well, the easy ones are 1 times 54. If you use your calculator, you'd find out that 2 times 27, 3 times 18, and then 6 times 9. Okay, now, kind of as I said before, if the signs in the parentheses are the same, you're going to add. But since the signs in the parentheses are different, you're going to subtract. So which two numbers, when you subtract them, will give you 3? Well, that's too big, that's too big, and that's too big. So 6 and 9 is going to be our answer. I'm going to put the bigger number first. And there we go. There is our factorization. Okay. Now the last one, I'm going to actually show you two different ways to do this problem. Okay. There's factor by grouping, and there is something called the bottoms-up method. Now in this case, again, you go through those mental checklists. Can you take a greatest common factor out? Well, 4, 19, and 5 don't have a common term, so there's no number coming out. And not all the terms have an x, so you can take an x out. So what we're going to do is those two methods I just mentioned. So the first one is called factor by grouping. So we're going to do 4 times negative 5 gives you negative 20. So you multiply the first and the last terms together. Then what you do is you find the factors of this that will make up positive 19 in the middle. So to do that, I'm going to multiply 20 times negative 1. So 20 times negative 1 equals negative 20, and 20 minus 1 gives you 19. Okay, so next we're going to replace that 19x in the middle with the 2 new factors we just found, plus 20x and minus 1x. Okay, now the reason it's called factor by grouping is because you group the first 2 terms together and then the last 2 terms together. All right, out of the parentheses, we want to take out our greatest common factor. So in the first one, we can take out a 4 and an x. If we divide everything in the first set of parentheses by 4 and x, we end up with x plus 5. All right, in the second set of parentheses, we have negative x and negative 5. So the thing we can take out is a negative 1. And what's left over is if we change all the signs, we get x plus 5. Now in this problem, or this type of problem, you know you're on the right track if this and this parentheses are both the same thing. If they are, then you're probably doing it right. If they're not, you've done something wrong. So now we take the parts on the outside, the 4x and the minus 1, and those become a set of parentheses. And the x plus 5 is their own set of parentheses, and now we have factored it. Now I'm also going to show you a different method off to the side here. That's called bottoms up. Okay, it's kind of a trick for factoring. It starts out the same way that we had before, where we multiply the first and the last terms. Okay, so we would have had the negative 20. We would have also factored it to figure out what comes in the middle. Okay, so that's the same, but from there it's a little bit different. We're going to take those 2 numbers, 20 and negative 1, and we're going to divide them by the number in front of our x squared term, so that would be 4. Okay, so out of those 2 fractions, we reduce the fractions if we can. So 20 over 4 becomes 5 over 1, and negative 1/4 stays the same. Okay, now we can put an x in the denominators, and that becomes called the bottoms up because that number on the bottom becomes the first term in your parentheses. So we have x plus 5, and then 4x minus 1. Notice it's the same answer as the other method. It's just found in a little bit different way. Okay, so those are how to factor some quadratic expressions. Hopefully this helped you out, and good luck.